In the name of God, in the name of without doubt escapable and voice, welcome to our own channel. Welcome to seventh episode of Learning SAP Software. In this episode, we are going to design and analyze the truss bridge. In here we have a truss bridge with length of 10.5 meter. It is the front section and it is the bottom section. In here we have three equal panel length, and each panel length has the length of 3.5 meter. And also in here we have the other member. It is also 3.5 meter height, and our crown point is with height of 4.5 meter. In here we have point in a panel points. We have the point loads or concentrated loads of the 5 kg and 100 kg, and also the width of our our bridge is 3.5 meter. It means that this type of the truss we have to provide in other side with distance of 3.5 meter. Our section that we have to design is I-beam section. Our compressive strength, minimum compressive strength is 250 kg per centimeter square. What does it mean by minimum compressive strength? Minimum compressive strength means that the minimum compressive strength of the concrete after 28 days is 250 kg per centimeter square. The live load that we have on the slab, that we provide the slab because of our pathway, so it is actually 500 kg per meter square. It's a UDL load. And then deck, the slab of the bridge also we can call the deck, and this thickness of the slab or thickness of the deck is 30 centimeter. Means that we have the bridge with the length of 10.5 meter, width of 3.5 meter, and deck of the 30 centimeter. And also the yield strength, minimum yield strength of the steel that we have is 3200 kg per centimeter squares. Means that what is a yield strength? Yield strength means that when our steel reach up to this 3200 kg per centimeter square the load, so actually it start deformation and it never come back, or it never obtain its original shape. And also yield strength, we can say it is the maximum behavior of the elastic and plastic, or is a point that elastic behavior of the section change to plastic behavior of the section. So let's start. First of all, we have to open our SAP program. Make sure with your units, kilogram, meter, Celsius is okay. Then Ctrl plus N. Select the 2D truss, and the type of the truss that we have is a vertical truss. Number of division we have 3 because 3 panel length we have, and height of the our section, if you see, 3.5 and 4.5. No matter that which value you gave there, if you first if you take 3.5 meter, no problem, and or if you get 4.5 meters also no problem, because we can edit the grade line. So now I take for preference 3.5 meter. Division length is also 3.5 meter because each panel length is 3.5 meter. And also section we can define from here, or also we can define from here. So for cords and for braces, so just click in here, import new property, select I-beam section and select sections.pro. Then select all of the section that you want to import. Okay. Then also now you have to sum all of these sections under one name. So add new property, auto select list. In here select all of them, add, and okay. And in here it is, the name was I think auto, so select the auto one. In here also select the auto one. What does it mean? Mean that we actually tell to software that select one of the best section, or select one of the best members or best steel section for our designing. Okay, so it is our truss. Okay, one thing that you should know, that in here we get this truss is a indeterminate knot. We select this truss as a determinate truss. Why? Because you know that steel deformation is actually depend on time. In winter it become compressed, but in summer it become extend. So because of extend and compress of the concrete, because of avoid of cracking in the concrete, they provide the roller support in this side. This cracking, whether it can be because of the shrinkage or it can be because of creep. Because of creep, not because shrinkage is the shortage of the volume of the concrete, okay, because of the moisture content or chemical changes, but creep is actually also shortage of the volume of the concrete due to repetitive load in a long period of time, and it contains some deformation. So we can say according to some shrinkage or other factor, because of avoid of the cracking in the concrete, we have to provide manual. Here also we have cracking because in a pathway we provide the concrete slab, okay. Then what should we do in here? If you see this joint, and this joint is 4.5 meter, so select this joint, right click, come in a location in here, change this as a 4.5 meter, okay. And also this point, select, come in a location 4.5 meter, okay, and also okay. Now what should we do? We have to get one copy from distance of 3.5 meter. So select all of them, Ctrl plus A, come in a edit, replicate, in a linear, dx, in a x direction we don't have anything, in a y direction we have 3.5 meter because our width is 3.5 meter, and a z direction also we don't have anything, okay, and okay. So now if you see here, now what should we do here? Now we have to join the joint with each other, and also we can label the joints. How? Just come in a set display options, in here select the label, apply, and okay. For example, you need level 15, so just no, and selection is difficult for you, so no need to that you select from here. Just come in a select in here, find the label, and in here write just 15, select, it will be select, okay. Now we have to join. So how we can join? It's very easy. Now here by drop frame cable we can join. Here select the auto, okay, then this point, okay, and also this point, and also we can provide bracing because of avoid of the deformation. Actually we didn't need to provide here, but because of avoid of deformation we provide. And also in this portion at the bottom side, yes, because of deformation and also because of taking the load of the slab we provide bracing also, but in here only because of the avoid of deformation. That, and at this portion also we have to provide. And at bottom side also we have to provide. Okay, like this, and also at this portion like this, and also at middle one. Okay, now in here also we have to provide the slab. So in here we have two options. This draw poly area we can use for 3D, and rectangular we can use for 2D. So draw poly area we can draw in here, just in here cam and select this point, and also cam here this side, select this point and select this point, okay. Now in here we can come in a what you can say in here, we can come in a edit or a view, set display option, general option, fill the object, apply, and okay. Okay, so now what should we do? First, another step, the come and define material. In a concrete we have to define. In here we can write the concrete, and we can get the color as a gray, okay, and kilogram centimeter, In here we can write 2.5 because it's a RCC. And compressive strength we have 250 kg per meter square. And then we can say okay. And here if you see, in here we have expected concrete compressive strength, we get 100 more. And then we can add new properties default by software, we cannot read. We can also add the new material, steel A36, okay, and then we can come in and modify show. Then we can change this for 3200. No, it is not. We have to change here 3200. Here we can get 3300, 3200 and 3300. Then here also we can change this 785. And now why I get expected yield stress, expected capacity is 100 more, because we say to software that our minimum yield stress is 3200, but if the load of 3300 also comes, it should react as a 3200, mean the yielding or deformation should start from 3300. We design according to these 3200, but if the load reach up to 3300, so it should react like 3200. So okay, and also okay. Then come in a load pattern, we have dead load, then we have the live load. Select live load, add new load pattern, okay, and then we have the load combination, add new combo. Dead load we have the 1.2, add, and then live load we have also the 1.6, also add, and also okay, and also okay. Then in here select your assign, we should assign. So come in a frame, in here we have to come for area, okay. So in here we should come for area section, and first of all we have to define the concrete. So we define the concrete, okay. In here no we didn't define section property, area section, so we should define in here. So now in here add new section, in here we can name slab. In here we have some options. Shelton means that when your thickness of your slab is up to 30 centimeter, 0 up to 30 centimeter, so or less than 30 centimeter or equal to 30 centimeter, we should select Shelton. Shelton if your thickness of slab is more than 30 centimeter. And Platen we use for wall. And then we have membran. Membran is our thickness before deformation. So in here our thickness is up to 30 centimeter, so we should select Shelton. And also our membran, mean thickness of our slab is 30 centimeter, so we can select 30 centimeter. And also because our unit is a meter, it will automatically change to meter. So bending means that thickness of our slab after deformation, so both of them 0.3. And then because of rebar, in here we have to add new material, we have to define the rebar also, okay. And here we can also change the name as a rebar, and we can select this color, okay, and okay. Now in here we can select the rebar, default is okay, rebar layout option default, that which option is better, the software will get decision. So now in here we can say also okay, and also okay. Now come in assign area section, select the slab, apply, and okay. Now select all of them instead of this slab. Come in assign frame section, find your auto 1, apply, and okay. Now what should we do? We have to so now you can see the extrude shape also, apply and OK. Now if you see it is our section that we design, extrude shape of our section. Okay, now what should we do? Now we have to come in a analyze, set analyze option. Sorry, before that we have to also uh, determine the loads. Okay, if you see for this joint, for this joint, for this joint and for this joint we have 50 kg. So come in as assign joint load forces dead load in here minus 50 kg because of downward direction, apply and OK. But for this joint, this joint and this joint we have 100 kg. So come in and assign joint load forces. In here we can select the 100 kg, apply and OK. And for the slab we have 500 kg. Come in and assign in here we have to come in and assign frame load, not area load, uniform to frame shell. Just select the live load and 500 kg, apply and OK. Now we have to come in analyze option, space truss, OK, and also come in analyze, do not run according to model, run now. So in a drive with D we can save Obaidullah. Then so it is actually our deform shape of our, if you see it's a deform shape of our bridge. Then we have to come in the design, now if you see it is our designation. In here one problem that we cannot design for concrete and for steel at the same time. You have to do for concrete separately in a new file and for steel separately. Okay, it is our designation. In here if you see our sum member is actually failed and then we have to change these sections. Okay, it means that we have to change this section for maybe for bottom chords we can change these sections. Okay, for bottom chords. So it is a designation. Have a nice time. Goodbye.